Today we're going to learn about direct variation. Direct variation is defined as when the rate of change between two variables are the same. Okay. All that means is that your independent and dependent variables change at the same rate. What that's going to look like as a graph is a straight line through the origin. If you think about if you babysit and you make an hourly wage, if you graphed it, it would make a straight line, because after you work 1 hour you make $12, 2 hours 24, 3 36. It won't change based on how long you're there. Okay, you make the same amount every hour no matter how long. The formula is y equals kx. And sometimes instead of k, you'll see an a. It's all the same. K is your constant of variation. That just means it's how fast or slow your line is increasing or decreasing. It's pretty much your slope. Okay? Now, if you think about it, we just came off of slope-intercept form, which is this. Direct variation is pretty much the same thing, except instead of m, you write a k. And since it always goes through the origin, our b is always 0, so you don't need a b. If you want to solve for your constant of variation, all you would do is divide each side by k, or by x, I'm sorry. So your constant of variation is y over x. You should get the same thing every time, which again shows it's like your slope, because if you remember, slope is your change of y over your change of x. So to run over that again, direct variation occurs when the rate of change between the two variables are the same. It's a straight line through the origin. If you go back to the babysitting example I gave, it makes sense it has to go through the origin, because if you don't work any hours, you don't get paid, so they're both at 0. The formula is y equals kx. K is your constant of variation, which is essentially your slope. And it's just like mx plus b, except instead of m, you write a k, and your b is always 0. So if you're given a table, and it says to write the equation of direct variation, first you've got to make sure it actually is direct variation. To do that, you've got to find your k, which is y over x, and you have to see if it's the same every time. So here, 6 divided by 3 is 2. 8 divided by 4 is 2, because I'm doing y over x. 10 over 5 is 2, and 12 over 6 is 2. So since I got 2 every time when I did y over x, I know my k, my constant of variation, is 2. So my equation is y equals kx. If k is 2, the equation of this line is y equals 2x. If at any point you divide your y by x and do not get 2, for example in this one, then it's not direct variation. The only exception to that is if they add the ordered pair 0, 0. Okay, that would still be direct variation, because that's your origin. Your first U-try is right here. You can go ahead and jot that down and pause the video if you need to. And then we're going to go to example 2. It says find the equation of variation when y varies directly with x and y equals 12 when x equals 3. If you're doing word problems for direct variation, it always says y varies directly with x. Okay? So the first thing we have to do is find our k, our constant of variation, which we know is found by doing y over x. So you plug in what you know. We know when y is 12, x is 3. So k equals 4. Now that doesn't answer the question yet. Okay, that's not the equation, that's just our constant of variation. So going back to your basic form of the equation, it's y equals kx. So I know if k is 4, the equation of this whole line is y equals 4x. Okay, and you're probably saying, why would I ever need to do this? Going back to the babysitting example, if you do this, then you could say, okay, if I get paid $12 an hour, 12 would be your constant of variation. You can easily figure out how much you would get paid after babysitting 6 hours. Here's your you try 2. You're going to need to write the problem down. Now, Mr. Ericon always does a riddle somewhere, so today what I'm going to say you have to write down is Mrs. Sauer is awesome. That's your riddle for the day. And we'll see if Mr. Ericon picks up on that. Okay, last we're going to do graphing. To graph direct variation, let's just start with y equals 4x. We know we're going to start at the origin, okay, because if you look at this in terms of y equals mx plus b, there's no constant. Okay, so you know if there's no constant, it's direct variation. So you're going to put a dot at 0. 4 is like my slope, that's my k. Rise 4, run 1, just like we did before. The other way to look at it is if k equals y over x, your k gives you an ordered pair. Since it starts at the origin, this will be an ordered pair. This is x and y. The ordered pair is 1, 4, which you can see we hit right here. Okay, so you can either use what you know about slope or create the ordered pair. Here's your last you try. And then one thing I want to tell you just real fast, this is not on your notes, but it's a good thing to know, and we'll talk about this more next class, is you have to be able to identify if something is direct variation or not. So this example here is not direct variation because it has a constant. This is an example of direct variation because there is no constant, and it's y equals kx. Okay, we'll work more on this next class. Those are your direct variation notes, and make sure you tell Mr. Ericon that Miss Sauer is awesome.